Bismillahirrahmanirrahim. Diodes are essential component in modern microelectronics and analog, particularly analog ICs. And their performance is governed by various design parameters. And these parameters are often available in the specification of the diode. And understanding of these parameters are very crucial, not only for the designing, but analyzing of the circuit. And here are the some key parameters that characterize the diode we will discuss in this unit. The most important parameter is forward current. The current flowing through the diode when it is in forward bias region. And similarly, the reverse current, which is very small amount of current that flow through the diode when the diode is in reverse bias. And now the third important parameter is reverse saturation current. This current flow when the diode in reverse bias when the voltage is very small and it is constant for the given voltage and is temperature dependent. Another important parameter of the diode specification is threshold voltage, also known as the forward voltage drop. It is a minimum voltage required to turn the diode on and allowing significant amount of forward current to flow. And typically around zero point 0.7 volt for silicon diode, zero point 0.3 volt for germanium diode, and closely 1 volt for gallium arsenide diode. Now we discuss about breakdown voltage. The reverse voltage at which the diode began to conduct significantly in reverse bias we consider as a reverse bias voltage. And generally, this voltage leading to serious potential damage unless it is designed for a specific purpose, just like as Zener diode. Now we discuss another important parameters of a diode is the dynamic resistance. The smallest AC signal resistance of the diode when it is operating in the forward region. And it affects how the current change with respect to voltage. We will discuss it in more detail in later slides. Capacitance is another important parameter for diode specification because diode exhibit capacitance due to their junction structure, which can affect performance, particularly at high frequency electronics application. And this junction capacitance includes both transition capacitance and diffusion capacitance. When the diode is reverse biased, the depletion layer is very large and the diode strong positive and negative polarities create transition capacitance. The amount of the transition capacitance depends on the reverse voltage we applied. And similarly, when our diode is in forward bias, the storage capacitance or diffusion capacitance exists as the diode voltage increases. Both capacitors are shown in graph very clear. And now the temperature coefficient will describe how the diode characteristics such as saturation current and threshold voltage changes with temperature. Power dissipation is another important parameter. The maximum power that a diode can dissipate without failure and typically defined by the product of forward current and the forward voltage drop. Similarly, reverse recovery time, the time it takes for the diode to switch from conducting in the forward direction to blocking in the reverse direction, we consider as a reverse recovery time. It is very important for high speed application. These parameters are crucial for understanding and designing diode based circuits particularly for analog VLSIs that incorporate diode, and as their influence on the diode performance is critical for many electronics applications. Thank you.